problem. So in this example problem, so find OBST for a set of identifiers. There are three identifiers are there, that is A1, A2, A3. These are the successful probabilities of three identifiers, and these are the unsuccessful probabilities of these three identifiers. First, we have to construct possible number of binary search trees. So how many possible number of binary search trees? So that is one formula is there, 2NCN divided by n plus 1. That is how many number of possible binary search trees. So is equal to 2NCN divided by n plus 1. That is equal to 2, n value is 3, C 3 divided by 3 plus 1. N is nothing but number of identifiers. So that is 6C3 divided by 4. So that is 20 divided by 4. That is equal to 5. Five binary search trees are constructed by using these three identifiers. First one, while is the root node. Next, if. Next, do. How we are writing? So in while identifier, first letter is W. In if identifier, first letter is I. W is compared with I, so I is less than W. Then we can write left hand side of W. Next, in do identifier, letter D is compared with I, so D is less than I. So do is present at left hand side of identifier if. Now we have to add external nodes from left hand side to right hand side. So this is E0 and this is E1. These external nodes are represented by using square boxes. So start with E0, E0, E1, E2. Next one E3. So this is the tree one. So cost of T1 is equal to first while. So this is at level 1, this is at level 2, this is level 3 and this is level 4. So first while belongs to A3, its probability is 0.05. 0.05 is multiplied with level of while identifier. Level of while identifier is 1 plus next if belongs to A2, A2 probability is 0.1, 0.1 into level of if identifier, that is 2 plus do belongs to A1, its probability is 0.5, 0.5 is multiplied with level of do identifier, level of do identifier is at level 3, is multiplied with 3 plus next external nodes E0, E0 belongs to Q0, its probability is 0.15, is multiplied with level minus 1. E0 is there at 4th level, 4 minus 1 plus E1 belongs to Q1, its probability is 0.1, so it is at the 4th level, 4 minus 1 plus E2 belongs to Q2, Q2 probability is 0.05, is multiplied with E2 is there at 3rd level, 3 minus 1 plus E3 belongs to Q3, its probability is 0.05, it is at level 2, so 2 minus 1. So this value is 2.65. Next we can take if as root node. Next, do is compared with if, so do is less than if, so do is present at the left hand side of if. Next, while is greater than if, so while identifier is at the right hand side of identifier if. So we are adding external levels, external nodes, that is E0, this is E1, and this is E2, and this is E3. So all the external nodes are at the same level. So this is level 1, this is level 2, this is level 3. So cost of T2 is equal to, if belongs to A2 probability is 0.1. So if identifier at level 1 plus do identifier belongs to A1, its probability is 0.5 is multiplied with the level 2 plus while belongs to A3, its probability is 0.05, it is at level 2 plus E0 belongs to Q0, its probability is 0.15 is multiplied with 3 minus 1, it is at third level, 3 minus 1 level plus E1 probability is 0.1 is multiplied with 3 minus 1 plus next E2 0.05 is multiplied with 3 minus 1 level plus next probability is 0.05 is multiplied with 3 minus 1th level. It is at third level, 3 minus 1. So that is equal to 1.9. Next, this is cost of T2 is equal to 1.9. Next one is do. Do is compared with if. So if is greater than do. So the identifier is at the right hand side of do. Next, while is greater than if. So while identifier is at the right hand side of if. So that is here E0. So external nodes can be sought at left hand side, then proceed go to the right hand side from left hand side. So that is E2, that is E3. First, this is the level 1, level 2, level 3, level 4. First, cost of this is T3. First, do belongs to 0.5 is multiplied with level 1 plus next if belongs to 0.1 probability is multiplied with 2 plus while belongs to A3, its probability is 0.05 is multiplied with its level, that is 3 plus E0 probability is 0.15, it is at level 2, that is 2 minus 1 plus next probability is 0.1 is multiplied with 3 minus 1 plus next probability is 0.05 is multiplied with 4 minus 1. Next probability is 0.05 is multiplied with 4 minus 1. So that is equal to 1.5. Next, this is cost of. Next one is this one. Next one is fourth one. While next do is less than while, it is at left hand side of while. Next, if is greater than do. So if identifier is at right hand side of do. Next, we are adding external nodes, that is we are starting at left hand side, then this is E1, and this is E2, this is E3. So this is cost of T4. Cost of T4 is equal to, this is the first level, second level, third level, fourth level. While identifier probability is 0.05 into 1 plus do identifier probability 0.5 into 2 plus if identifier probability 0.1 into 3 plus E0. E0 probability is 0.15 is at third level 3 minus 1 plus next E1 probability is 0.1 is multiplied with 4 minus 1 plus E2 probability is 0.05 is multiplied with 4 minus 1 plus E3 probability is 0.05 into 2 minus 1. So the cost is 2.15 this way. Next, this is the first tree and this is the second tree, this is the third tree and this is the fourth binary search tree. Last one 5 binary search tree, last one 6th binary search tree. 5th binary search tree is do is compared with while it is greater. So while identifier is at right hand side of do. Next, if is compared with while if is lesser. So the identifier if is present at left hand side of while. Then we are adding. So this is E0. This is E1. This is E2 and this is E3. So this is first level, second level, third level, fourth level. So cost of T5 is equal to cost of T5 is equal to do. Do belongs to A1, its probability is 0.5 into 1 plus while identifier belongs to A3, its probability is 0.05 is multiplied with 2 plus if identifier its probability is 0.1 is multiplied with 3 plus E0 probability is 0.15 so is multiplied with 2 minus 1 plus E1 probability is 0.1 is multiplied with 4 minus 1 plus E2 probability is 0.05 is multiplied with 4 minus 1 plus E3 probability 0.05 is multiplied with 3 minus 1. So the value is 1.6. So after completing these 5 binary search trees, so which binary search tree contains the minimum cost value? So that binary search tree is optimal binary search tree. First binary search cost is 2.65. Second binary search cost is 1.9. Third binary search cost is 1.5. Fourth binary search cost is 2.15. Fifth binary search cost is 1.6. Among them, so the binary search tree. So T3 has the OBST. T3 has the OBST. So this is the optimal binary search tree for these 3 identifiers. So in this way, we have to find out the optimal binary search tree by using this formula. How many number of possible binary search trees for the given identifier tree? That is 2NCN by n plus 1. That is 5 binary search tree. After constructing these 5 binary search tree, which binary search tree contains the minimum cost, that binary search tree can be treated as optimal binary search tree. If the number of identifiers are 3, it is very easy to construct 5 possible number of binary search trees. If n value equal to 4, so it is very difficult to draw all the binary search trees and find out the cost. So at that time, we are using dynamic programming. By using dynamic programming, we have to find out the optimal binary search tree directly without constructing all possible binary search tree. So by using dynamic programming, how to find out the binary search tree for the given identifier is discussed in the next video. Thank you for watching this video. If you like this video, please subscribe my channel name Divvela Srinivasa. Thank you.